Hello, my name is Christopher Fabian and my student ID number is 21055311079 and my lecturer is Mrs. DWIDIANI, and today I'm gonna presenting to you guys about Vickers hardness testing that we have practiced about like 1 month ago. So the basic theory is hardness test is used to determine the material's ability to load in a constant change. The test object will experience deformation, which permanent deformation when a certain loading force is applied to the test object. We can analyze the level of hardness of the material through the amount of load given to the area that receives the load. We must consider the strength of workpiece when selecting the material of the workpiece. With that in mind, we tend to choose a workpiece material that has a higher level of hardness. The reason is, hard metals are considered stronger when compared to soft metals. However, harder metals tend to be more brittle and vice versa. So when you want something to be ductile, the strength is gonna be a little bit lower and it easily become like bended. Then it can be like more elastic deformation, but when you have like a hard or strong metal, it can be so much brittle and it's easily to be broken. So it depends on what material we're gonna use on our things, on our project. Hardness testing aims to determine the hardness number or hardness level of the metal. The hardness testing method consists of pressing, scratching, and dynamic. And this one we're gonna try to use the pressing one. And the compression hardness testing method is the Rockwell, Brinell, and Vickers method. The Brinell and Vickers methods are focusing on calculating the strength of material for each cross-sectional area that receives the load. Meanwhile, the Rockwell method focuses on measuring the depth of the pressure or indenter, and that forms the beam indentation on the test object. And the difference is the way this test produces. The unit value is also different, therefore each test has its own unit according to the pressing process, which is recognized by international standards. The difference in the units are shown in the written form of the test results. So let's begin on the practice. We need tools and materials. Of course, we need hardness testing machine, microscope, pyramid diamond indenters, vernier calipers, so we can like scale, like measure the thickness and the size of the object. Grinding machine, so we need clear surface, and then we put it in chloride or natrium chloride, if you know that. So it has like clear surface. I'm not putting it here. And then the last test object, or we are using the Vickers iron. Steps: take measurement of the specimen according to the specification given to be tested, and then smooth one side with sandpaper, and then polish and then etch with natrium chloride, and check load, diameter, and timing gauge. Load the surface 5 times. We are using 3 times here because the size of the object is not really big, so we only can able like put it 3 of indentation. And then the last one, transfer the specimen to the microscope and measure the diameter of each the indentation. So we have like basically the steps. First one is the grinding, and then after that we need to put it into the natrium chloride. So we like just let it sit for like about 2 minutes, and then we clean it, of course, put on hardness testing machine, and then press with diamond indenters. So this one, on this part, it's diamond indenters with the size of really small, and apex angle is about 136 degree. And then after that we have the results like here, and we need to analyze this one and calculating the how much strength the Vickers iron have. So how to determine the Vickers hardness value with this formula: 2 times P times sin, and then this one apex angle divided by 2 and divided again by diameter square, or we can like simplify to 1.854 P divided by D square, and the value is gonna be on kilogram times millimeter square. So the description on P is for load, D for average diagonal, and theta is for apex angle. We are using 136 degree. And the scale we have on the microscope is scale for A is 0.1 and scale B is 0.2. And A on here later we are using that for indent area. So which line? For searching D1 we are using A1 times scale A times plus B1 times scale B. So after that we get on D1 and D2, we put it into the average D. It's D1 plus D2 divided by 2. Of course it's in millimeter. So after the testing we have the results. A1 have 3 columns, so when you are checking on the microscope it has like row and column. So the A1 we have 3, A2 we have 3, and A3 on the indent 3 we have like 3, and of course we can see on the table here. So after the testing we just put it into the formulas. We search D1, A1 times scale A times B, plus B times scale B. So 3 times 0.1 millimeter plus 13 times 0.02 millimeter. So we have the results 0.56 millimeter. And also on the D2 we have 0.58 millimeter. So the average of diameter is gonna be like 0.557 millimeter, and the hardness value we have 57.06371 kilogram per meter square. It's millimeter square. And we have on the second indentation we have 71.28028 kilograms divided by meter square, and also the last one we have 68.56509 kilogram divided by kilogram per meter square. So now we have on the table here the object all are Vickers iron, and the indent diagonal is we put like before, and D1 is 0.56 and D2 is 0.58, and the average is 0.57, and Vickers hardness value we have 57 times 0.6371, and after all the calculation the average of one of like the object is 65.63636 kilogram divided millimeter square. So the conclusion is that the hardness level of the test material from point 1 and then the point 2 and point 3, the average of Vickers hardness is 65.63636 kilogram per millimeter squares. And the conclusion is the material is pretty hard and pretty brittle, but because it's on the small size we cannot measure how strength of the material, so we just know how is the Vickers hardness from the material. And after that we are testing on metallography. We can see that the material of the Vickers iron is really beautiful because it has like still like very hard, but also it has like a lot of iron as well inside there. So that's all for today, and see you next time.